First, we'll understand what are those important factors which we have to consider while selecting the right material. Here, I want to ask you this question. Imagine you are a product design engineer and you have to select the material while designing a cross member of a chassis, for example. So which are those important factors which you have to consider while finalizing the material? Can you type in the chat box? And one by one, I am going to explain you all these points. Yes, Taufik, very nice. Number 1 point is strength. Yes, Devkinandan is saying design temperature, very nice. Taufik is saying cost, very nice, very important point. What else? So the first point is strength. As a design engineer, you have to visualize the various types of failures. For example, I'll give one example. Suppose you are in tool design department and you have to design a tool like say plastic mold, okay? And that plastic mold is mounted on the machine plate. So you have to design some fasteners, for example, the size of the screw or bolt, whatever it may be. So here, which type of failure will be there? For bolt, it will be a shear failure. So when you are selecting the right material, you have to visualize or we have to understand the type of failure. As per that, you have to select the material as per the required shear strength, right? So shear failure, that means shear strength. Similarly, you have to visualize the functioning of the part and then you can decide the strength of the component. So when you select any material, basic things you must know, that is various properties of material, like maybe tensile strength, compressive strength, shear strength, torsional strength, like that. Coming to the second point, accuracy. As a product design engineer, you have to finalize the tolerance value or accuracy. There are three terminologies. One is accuracy, second is tolerance, and third is quality. They are very similar in nature. So if the accuracy you want is say 5 micron, then similar material you have to select. You cannot go for wooden material or thermocol material, even though they are engineering materials, right? There are many materials available. So in such cases, if you have to go for 5 micron accuracy, definitely the choice will be steel or aluminum, that way, means metals. Then coming to the third important aspect, as Taufik explained this, cost. And cost should be a parallel thinking. Here I want to give you one very important interview question. You can note down. What is the question? How you will reduce the cost of my product? That is a general question generally asked during the interview. So there are many answers of this question. So one way how you can reduce the cost is you can change the material of the component. You can change the process. You can go for simplification of design. You can minimize number of components. Even you can delete the component. You can change the thickness or size, compact design. There are so many aspects how you can save the cost of your product. And cost should be a parallel thinking. Means whatever activity you are doing right now, means you are working as a product design engineer or quality engineer or production engineer, always think how I can reduce the cost of my product. There are various ways, and give this benefit to your company, ultimately to the customer. And don't think how much effort you are putting. So cost is very important aspect. And if you are not sure about the cost, today I'm going to share that with you also, the rates and what is the market situation right now. You can take help from purchase engineer. He is there in the market every day. So before finalization of your drawing, go to him, show your drawing and ask him that I have specified this material. Is it okay? And he may give you a very good suggestion that he will say, don't provide this. There is cheaper material available in the market and with the same quality or same strength. So value engineering is very important. And what is value engineering? Reducing the cost, keeping the same quality, or improve the quality, keeping the same cost. That is value engineering. And always think about value. Now today's session, if you are getting 1 point and if you are implementing this in your life, I think it's a fruitful session. That is value, right? So same thing you have to consider whatever activity you are doing in the industry. And you must know the current charges of material and like steel material or even aluminum material. And these are changing, means every day material rates are changing. You should have that knowledge. Coming to the next point, that is quantity. How many components you want to produce? As per that, material will change. If you are in R&D department and you have to go for some prototype activity, means you are not sure about the finalization of the design, you can go for a material that is called as a soft tooling material. Means in case of dies and mold, there is a concept called as a soft tooling. Soft tooling means if the design is not freezed, means trials and errors are required, you can go for soft tooling material and you can conduct some trials, and if you found okay, then you can go for the finalization of the design and tooling. So as per that, you have to go for different materials. Coming to the next point, that is complex geometry. Now, why this point is very important? When you are designing a product, how you provide the shape, it is as per the function, it is a requirement of your customer. There are various aspects of design. And sometimes you may have to go for a complex shape, like in case of engine head, manifold, gearbox housing, or engine block. The shape has to be critical because there are so many functions you have to achieve. And when you design your product, there should be a parallel thinking that how I'm going to produce this component. So if the complex part is there, then as per that material you have to select. And there is again a wide range of materials. So if the material is very, we can say the complex geometry is there like engine block or engine head, then you have to select the material which can be processed further. So there are many points simultaneously you have to consider. Means one thing is that you are selecting the material, but at the same time, you should have that visualization that how I'm going to produce this component. That point also we are going to study right now. Next point is surface finish. What is your requirement? If the component is aesthetically very important, you may have to go for triple triangle or even 4 triangle surface finish symbol. So if you have to achieve that symbol, same material should be selected which will produce that surface quality, right? In case of steel, you will get more surface finish or good surface finish compared to cast iron. That we have to understand. Even aluminum is better than cast iron. Then cast iron is better than rubber, for example. Rubber is better than wooden, like that. So that way you have to consider the point. Coming to the next point, that is size of the part. Imagine the size of the part is say 2 gram or 3 gram. Then there are some limitations for the material to select. Again, visualize the job size of say 10,000 mm. Then again the material limitation will be there. Not all component materials can produce such huge components. So that way limitations also you have to consider. Coming to the next point, machinability. Now this part is related to machining processes. So if you consider cast iron and steel, which is having better machinability, can you type in the chat box? There are many design engineers I can see in this room. If you have to machine cast iron and steel, which is giving more machinability? I want to see your answers. Yes, Kunal, absolutely correct. Very nice. Thank you, Alok. Thank you, Ashim. So machinability, you have to consider. So if machinability is good, that means your machining time will be reduced and your cost can also be reduced. That way we have to think. Coming to the next point, ease of manufacturing. Ease of manufacturing means DFM, design for manufacturing. Here I want to give you an example and you can answer this question. Imagine there is one plate. The material is a, you can say steel material, right? And there one cavity you have to create. The length of the cavity is say 10 mm, width of the cavity is say 2 mm, and depth of the cavity is say 7 mm. So how you are going to manufacture this? Can you type in the chat box? There is one plate The length of the cavity you have to create is 10 mm, width is 2 mm, and depth is 7 mm. So how you are going to create that cavity in that machine plate? Alok is saying drilling, Kunal is saying milling, laser cut, Vinay is saying milling. Okay, friends, nice. Nice attempt. But friends, just imagine when this is the cavity, if you are say drilling, what is the drill bit size, minimum size you are getting? That knowledge you should have. That machining knowledge you have to acquire. And why this I'm telling to you, I want that each one of you should work in the industry independently. You should not take help from anybody. And the day when you achieve this, you will not remain design engineer. You will become project leader. You will become manager. And what happens if you show ignorance in the company? People they may take undue advantage. This should not happen. So ease of manufacturing here, to produce this cavity, you have to go for EDM, right? Electro discharge machining. And if this is a process, then suitable material should be there. You cannot go for different materials. That is the limitation, what we have to understand. Next point, ease of modification. As a design engineer, you must have observed that there are many times changes are there as per the customer, sometimes because the management is not happy with the design. And when you have to go for changing the design, whatever material you are selecting, it should have that flexibility that it can accommodate that changes in the same material or parent body. So if that is not there, then you may have to go for some insert fitting or welding or some other processes which may not give proper feel or customer may not be happy about that. That we have to understand. And as per that, you have to select the material which will be having that flexibility. Next is weight. Weight means sometimes weight is a constraint for the functioning or capacity. Means for example, there is one machine and that machine can handle a particular weight of the component. So if that is the case, then you have to change the material. Like another example of a car. Many components, you must have seen last 20 years, lightweight materials we are using. We are approaching for different materials, even carbon fiber also. We are exploring the possibilities. The reason is that when you are reducing the weight, that means you can give this benefit to your customer because your fuel economy is improved, or maybe your cost of the product is reduced. That is the benefit. Next is the life. Means what is the life you want to achieve? Means this is one input for a design engineer. When you are designing any product or any tool, this is one input. If you don't have this input, you can ask your customer what is the life you want to have. As per that, your material will change. Next point is availability. This is not a technical point, but you have to consider. Sometimes you may attend some seminars or webinars, and there you got to know that this material is there. And if you apply that on the drawing, when you release the drawing, purchase engineer or the people, they will say that this is not available in the market. So when you are selecting the material, just cross check with the market availability. Next point is working conditions. What is that temperature? What is that pressure? What is that load coming on that particular product? As per that, you have to go for the right material. If the temperature is very high, then there will be limitation for plastic material or rubber material. Atmospheric conditions. If you are designing a car, you have to consider various temperature variations. That car can be used in Jammu and Kashmir, Rajasthan area, Tamil Nadu. So as per that different condition, or sometimes you are designing a vehicle for export quality. So that variation, what will be that effect on the material? As per that suitable material you have to select. And next important is manufacturing process. Very important. I told you, when you are designing a product, at the same time, there should be a parallel thinking how I'm going to manufacture this component. And for a particular material, I can show you this with one example. So I have one component with me. This is the component and the material is aluminium. Can you type in the chat box how this component is manufactured? What is the manufacturing process? I want to see your answers. This is the component you want to produce. This is a manifold of a two-wheeler. how this component is manufactured. Yes, Nilesh, absolutely correct. Very nice. Thank you, Alok. Absolutely correct. Yes, Vinay. Awesome. Anil Kumar, perfect answer. So this is produced by die casting process. So if you say casting, again, there are many processes available like die casting. In die casting, there are processes like low pressure die casting, high pressure die casting, gravity die casting. Again, in casting, there is a sand casting also. So out of all these processes, which is that specific process? That is die casting, right? In die casting also, again, you have to there should be a precise answer. So this component is produced by gravity die casting process. Very nice. Thank you for this. Let us understand other aspects. So here, this is one important aspect I want to explain you. You have to just focus on 5 materials. That's it. Whatever field you are working right now, you are working in as a quality engineer or production engineer in automotive industry or tooling industry, just focus on these 5 materials. And what you have to study, you start from the density of material, for example. So here one important question generally asked during interview, you can note down in your notebook. Draw one cube, give dimensions 100 mm by 100 mm by 100 mm. Material is cast iron. Density of cast iron is say 7.2 gram per centimeter cube. Find out the mass. Okay. Drawing I have given, that is a cube. Material I have given, find out mass. This is frequently asked question during interview, and not just for interview. Day-to-day life, you have to find out the mass. Of course, softwares are there, but if you are not in front of your software or computer, you are at remote places, you should be able to do this activity right from raw material procurement up to dispatch. This is one element which is very, very important. So why only 5 materials I have specified? Take any industry, say for example, car manufacturing company. Just visualize the body components. Body components are produced from steel material. Dashboard of a car, the material is plastic. Tires, oil seal, belt, the material is rubber. Piston, clutch housing, gearbox housing, the material is aluminum. Engine block, material is cast iron, right? So that way, when you see any component, you should have that visualization. And at least you should know the nomenclature, means you should know the part names of any component, like automotive component, like example of a car. And why I am giving example of a car, most of the industries, mechanical industries, they are related to automotive industry. That's why this point is very, very important. So one by one, we'll understand this. So first material is cast iron. And if possible, you can note down all these aspects. Don't take, I will not prefer taking screenshots. Why it is like this? Because when you take screenshot, there is a high probability that you will not see that after this webinar. And when you write this, writing, one time writing means 10 times learning. That is the ratio we understood in our school days. So same thing is there. So carbon percentage 2.5 to 4%, silicon 1% to 2.5%, manganese 0.4 to 1%, sulfur 0.06 to 0.12%, and phosphorus 0.1% to 1%. Now this may change slightly. This is just to give an idea about the contents. So you must know which are those important elements in cast iron. And at the same time, suppose if you add phosphorus in cast iron, which properties you are going to achieve? If the content is changing, that knowledge you must have. Then basic requirements like various strengths, ultimate tensile strength, this is the range, then compressive strength, shear strength, and hardness. Hardness is in BHN. Here, one thing is important, that you must know what are the various inspection methodologies. So if it is a cast iron component, the hardness is checked in Brinell hardness number. And most of the time for steel, it is checked in terms of HRC, that is Rockwell hardness C scale. And for cast iron, compressive strength is more than tensile strength. Then you must know the applications where cast iron is used and types of cast iron. One is gray cast iron, that is the most commonly used cast iron is gray cast iron. Spheroidal graphite iron means SG iron. This is also called as a nodular cast iron. And what is the difference here? See, one side this is cast iron and this is say steel. Steel is having high tensile strength. Cast iron is having less tensile strength. Steel is having poor castability property. Cast iron is having good castability property. Now this in between is the SG iron, that is spheroidal graphite iron. Why it is called as a spheroidal graphite iron? Because the carbon is in the form of spheroids, and this is also called as a nodular cast iron. So SG iron is having better castability than steel, yes, but less or poor castability compared to cast iron. So SG iron material you are using when you need complex geometry, when you need the application like vibrations or impact loads are there, all these components, the material is SG iron. This is again one important question generally asked during interview. Next. So these are the major types of cast iron. There will be other types also, but in industry, whatever is that means practically most commonly used, these are the types. Coming to the advantages. If you are using cast iron, what is the advantage? Number one is low cost. Low cost. If you go to Kolhapur or Belgaum area, you will find there are many foundries and you will get the casting with the rate of raw material also for simple components. Second is excellent castability property, means it can get any shape. You can create any complex geometry because of this property. Good machinability, good compressive strength, available as per the requirement. That means what is your requirement? Shape and size. You can get that material unlike steel. In case of steel, whatever is available in the form of size, you have to purchase. But for cast iron, you can get the material as per your required shape and size. Intricate shapes are possible. Yes. Why? Because of the flexibility of the process. But at the same time, we must know the limitations of this material. If you are using cast iron, you have to be very careful that this is a brittle material. So careful handling is required. Low finish compared to steel means by just appearance, you should be able to visualize the material. So you will find that cast iron surface finish is poor compared to steel. Prone to rusting, yes, so careful storage is required. And heavy weight means if you want to go for some applications, you have to consider this point that like conventional processes, this may not be suitable. Next, application, engine block, engine head, gearbox housing, clutch housing. These are the automotive examples. Other examples like machine beds and fixture frames, cast iron can be used. Next important material is steel, and you have to master all these materials, friends. I told you, you have to start from the density of material. Then you must know the various properties of material, like start from the ductility, malleability, toughness, resilience, hardenability. Then you must know the alloying elements of each material. What is that? Carbon percentage, iron percentage, silicon, manganese, sulfur, phosphorus. And then application. These are the main areas where you have to focus. Then this is one very commonly used or asked question during interview. What is the question? What is the difference between cast iron and steel? And these are the important points you have to share. One is carbon percentage. So can you type in the chat box, what is the carbon percentage in steel? So the range is from 0.03 up to 1.2%. And as per the carbon percentage, there are three types of steel. One is low carbon steel, medium carbon steel, and high carbon steel. Low carbon steel, we also call that as a mild steel, right? So the mild steel, the percentage is up to 0.3. Medium carbon steel 0.3 to 0.6, and high carbon around 1%. That is above 0.6%. That is high carbon steel. Then types of steel, that is steel and cast iron. What are the various types? That is one point you have to mention. Then raw material availability, as I mentioned that for steel, you have to be dependent on the market. But for cast iron, you can get the desired size and shape. Then strength. In case of steel, it is having high tensile strength. But in case of cast iron, it is having high compressive strength. Surface quality, steel is better than cast iron. And specific gravity, 7.8 for steel, 7.2 for cast iron. Next. Then types of steel, broad categories. It's a huge subject, but general application, carbon steel. In that, three categories: low carbon, medium carbon, and high carbon. Alloy steel, huge area. Tool steel and stainless steel. These are the main types of steel, but this part, there may be many types of steel like spring steel, and other steels are also available. Advantages: if you are going for steel material, high strength, better accuracy, better finish, thin sections can be made. This is one requirement of a product, that when you are designing a product, you must understand what is the minimum thickness you want to achieve. And there are very few processes which can produce thin sections. That is one capability you have to consider. So in case of cast iron, that is not possible to produce thin sections, which is possible in steel. Limitations, again, heavy weight, raw material as per the market availability, and difficult to cast. So casting means steel can be casted, but there are problems while solidification of steel. So many times there are some defects in steel, but still we can produce the casting of steel, but not like as cast iron. The next important is aluminium. Advantages: if you understand, lighting weight, excellent castability property, same way like cast iron. You can create any critical shape in aluminium because of this point. You can create engine head, you can create clutch housing, you can create gearbox housing. Why this is possible? Again, having good castability property. Then excellent machinability. It is very smooth for machining. Excellent surface quality, better than cast iron, even steel. Corrosion resistance, right? So it is not affected by the atmosphere. And when we say lighting weight, many components nowadays are being replaced from steel to aluminium, cast iron to aluminium, because of this important aspect. Limitations: less strength, yes, even though other benefits are there, but when the point comes, the desired strength, aluminium will be second or third. Soft material, so careful handling is required. Then high cost. Cost of the aluminium is very high compared to steel and cast iron. Applications: engine head, gearbox housing, clutch housing, intake manifold, exhaust manifold, piston. Other applications like air conditioning of a car, radiator parts. There are so many brake components, various tanks. Even in case of various pumps, you can go for aluminium. You can go for other components like parts of refrigerator, washing machine, home appliances. Then next important is the plastic. And plastic, there are two types of plastics. One is thermoplastic and another is thermosetting. So the basic difference here, thermosetting plastic cannot be reused, but thermoplastic plastic can be reused. And most commonly we are using thermoplastic material. Here, what are the various types of thermoplastic? You can see on the screen, that is PP, polypropylene, LPD, HPD, polystyrene, ABS, acrylic, PVC, polycarbonate, polyamide, nylon, nylon 6, nylon 66. So many materials are available in the market. And another type is thermosetting plastic. Thermosetting plastic types like alkyds, urea formaldehyde, phenolics, epoxins, melamine. And you can see the application of this. Thermosetting plastic, one application, electric switches. You must have seen that if some sparking is there or some problem is there, you must have seen the appearance is blackish, right? So it cannot be reused, that we can understand. And same way, when you say thermoplastic plastic material, what is the process? And when thermosetting, what is the process? Means there are some definite processes where you can produce these components. That limitation part also you must know. Advantages of plastic: light in weight, low cost, easily available, can be recycled, excellent finish, can be easily molded, different colors available, and better aesthetics. Limitations: less strength, not suitable for hot conditions, like if you are designing a car, engine components. Because of these temperature conditions, you have to be very careful and conscious decision is required. Less accuracy. Less accuracy, when we say less accuracy, compared to what? Compared to metals. You may say that accuracy of plastic we can achieve in microns. Yes, that is possible. But again, when you consider 8-hour production, what is that regular accuracy you are getting? That accuracy we are mentioning here. So very few times you are getting that accuracy. Then disposal of plastic is a tedious job, means it requires many years to decompose. That's why it is not environment friendly, not good for health. You must have seen that there are bottles. At the bottom of bottle, there are numbers. And as per that number, whether it can be reused or not, that we have to decide. Difficult to produce complex geometry. You may not be agree with me that you may say that, okay, we can produce any complex geometry, but you have to compare this with components like engine block or engine head. If you compare that with that, plastic cannot produce very complex parts. Yes, to some extent, we can produce complex geometry. Next. Now, here's the criteria we have to understand. Selection of material as per the product tolerance. Initially, we understood the various factors. Now, when you consider all these materials, if you say product tolerance, if you want to go for a very good tolerance value, that better accuracy, then here in this case, aluminum and steel are better than cast iron, right? Again, cast iron is better than plastic. So that way, as a design engineer, you have to have that numbering, which is better. Coming to the second point, that is as per the surface finish. If you want to go for a good surface finish, even plastic is better, aluminum is better, steel is better than cast iron. Then cost. You must know the costing part that I'm going to share right now. So understand this. Cost is in terms of what? What is the unit of that? Cost can be per kg. Cost can be per square feet. Cost can be cubic meter. Cost can be per liter. So what is that criteria that you must know? So in case of cast iron, if you are procuring the material, it is in terms of kg, right? So most of these materials, the required, that means product cost in terms of mass, or that is the kg. But at the same time, when you are processing that, then the costing is changing because you are processing it. So raw material, then process, and then the output. As per that, raw material may be in terms of kg, but when you are processing it, then it may be per piece rate, or it may be per, we can say, square mm or square centimeter, like that also. Next is selection of material as per the process. I told you, when you are designing a product, next level visualization is that how I am going to manufacture this component. So if it is cast iron, very few processes are there, like you can produce the component by casting process. But for steel, you have better choice. Steel can be produced by casting, steel can be produced by forging, steel can be produced by rolling, by extrusion, by machining. Various aspects are there. And steel is having wide range. So apart from that, which is the better solution as per the particular aspect, that conscious decision you have to take while deciding the right material. Then if you understand aluminum, aluminum can be processed by sand casting or die casting. Then plastic, plastic can be produced by injection molding, blow molding, rotary molding, compression molding. There are again various types of processes. And if you have this choice, then Whenever you release the drawing, there will not be any modifications further. That is the number one performance measure of a design engineer. What is that? In good companies, when you complete 1 year of your, we can say 1 year working, HR, they are having their policies. They will give you appraisal form. And as a design engineer, number one performance measure is first time right design. Means whatever activity you are doing, like you are releasing the drawing or you are releasing the model, there should not be any modifications afterward. There should not be mistakes in your design. That is related to quality. So I was telling you that when you select the component, after that, there should not be any changes and the cost will be very, very high. If you say, for example, if you want to change the process from casting, that is sand casting, to die casting, total tooling will be changed. So it's a wastage of total tooling, and single tooling cost may be in lakhs of rupees. If you consider the tool cost, right from 2 lakh rupees, 10 lakh rupees for single component, the cost of tool may be 1 crore also. So this is a major decision. Next is selection of material as per the complex geometry. Here I told you for aluminum and cast iron, there is no limitations. You can go for any critical shape, but there will be limitation for plastic, to some extent to the steel. Next is that material cost. I told you this is changing every day. It is changing and you should have better idea about this cost, not only just for design activity, but if you are an entrepreneur, again you have to understand the effects of inventory and other things, because this is a very volatile market. Everyday market change, that cost changes there. So cast iron, if you consider the situation before COVID, it was almost half the price, means 45 rupees, 50 rupees was the cost. Now it is more than 80, 85 rupees. For steel, it is even for 200, 250, 350. For imported materials, even it is 800 rupees per kg also available, depending upon the composition of material. For tooling material, it may be even higher. Aluminum, the general cost is around 270 rupees per 350 rupees per kg. Now, this is today's situation, and it may slightly change as per the city also. Then plastic material, raw material, it is in the form of granules, right? And as per that, you have to add some elements in that. And sometimes people, what they do, they also recycle the material and they also add that in that particular raw material. But what happens here, when you are mixing that, if it is above the percentage, which is not, we can say, suggested, then it may affect the quality of your product. Next, die material. Now we understood the product materials. This is one important area, that is tool design area, because most of the components, if you visualize, like car components, body components, they are produced from press tool operations. So here you need to go for a press tool dies. So there are various types of dies, like maybe forming die or drawing die, blanking die, piercing die, trimming die. So for that, die material is required. And for plastic components, plastic mold, right? Then for plastic mold, different materials. If it is engine block, say casting, then you may have to go for cast iron material. So in that you have to go for sand casting. For sand casting, the tool name is pattern. For rubber, it is rubber molding process. So rubber mold is required. For forging, it is forging die. And for die casting, it is die casting die. So die and mold, very similar terminologies, but again, you have to use the correct terminology. If you say plastic die, that means you are not from plastic mold industry. And if you say forging mold, again, you are not from forging side. So people, they will recognize you or understand you from your background and what terminologies you are using. So here die material is very important, because if you consider 10 lakh rupees is the cost of the die or tool, around 35 to 40% cost is contributed by the cost of the die material. And this is a very conscious decision you have to take. So hot die steel is most commonly used die material. And there are two grades in this. One is H11 and another is H13. So what is the difference here? The difference is in chromium percentage. OHNS, oil hardened non-shrinking. That is one popular material used for various molds and dies. If it is a press tool die, for forming dies and drawing dies, you can go for OHNS. For plastic mold also, or for die casting also, you can go for OHNS material. HCHCR means high carbon, high chromium. This material is mainly used for press tool dies. And when there are cutting operations, generally you are using this particular material. And cast iron, this is also a tooling material. And where you are using this, you may use this for foundry application. So these are two aspects. One is product design, that is number one. And second important is tool design, that is number two. But if you want to become a good product design engineer, you must know tool design. You must know the limitations of these toolings or the process parameters when you work in tooling area. And when you are working in tooling area, you will understand the various concepts of tooling. Like one of the important concept is parting line, and it depends upon the various aspects also. And same way, again, it is related to the material selection as well as your product shape and product material. So friends, thank you for joining this session. Today, I shared some secrets with you. Go into the depth, and when you are going for the interview, just go through all these points and you will be ready to rock.